This is how real-time voice AI work, and this is how they work when they don't work in real time. They seem like they are very similar, but in fact it's going to have a huge impact on the code that you're going to use. In this video I'm going to use Python just to illustrate what I'm going to talk about. And choosing between real-time versus not real-time code is going to help you set up the framework that you're going to use on your server. So it's going to have a huge impact on the code. For the past few weeks, I've been working for one of my clients to implement a real-time voice AI agent. So I'm here to explain to you everything that I learned. And it all starts with understanding how it works when you don't work in real time. And this is what we call a synchronous implementation. So this is when everything happens sequentially. It's really straightforward. I'm going to explain to you how the workflow goes. So we're talking about a voice AI, right? So the first step is I talk to the AI. I am the user. And so the AI listens to the sound. That's step one. And step two is the sound stop coming to the AI because I stopped talking. But here's the thing. This is just a little pause in the way I talk, right? Like right now, I keep talking, but between the words, there are small pauses. And sometimes I just take a break and then I keep talking. Because maybe like I'm going to be thinking about something and that's why it's going to be a little bit, there is going to be a little pause where there is not going to be any sound going to the AI. And now that's the question, right? What is happening to the AI while there is no sound? And the answer is nothing. Like the AI is just in listening mode. And here's the thing, we don't have time to waste here in a real-time system not doing anything while nothing is happening. Because there are things to do, right? Like the sound cannot be processed by a large language model. Large language model being like ChatGPT, for example, right? Because what's happening under the hood is there is a large language model that is going to use the text that has been transcribed from the sound in order to process it and then reply. So we actually need the text from the audio. And that's a task that could be done while listening. But that's not how it works here because we are only in listening mode. And that's what not real-time processes are doing because we're just doing one thing at a time. And so as long as the user is not done talking completely, which is like, for example, when there is going to be a long pause, well, we're just going to keep listening, even though we could use those that time for the CPU to do other tasks. So when the AI is done listening to nothing, we go to step 3, which is the AI keeps receiving sound. So this is what we are used to. This is the type of implementation in Python that is very straightforward, and that's the easiest to set up. And the example that I'm going to use here for the framework is the one that I used personally, which is Flask. Now let's go to the real-time implementation of how to do this. And this is called an asynchronous implementation. And the first step is the exact same as the synchronous implementation, which is just the sound coming to the AI because the user is talking. And then the second step is still no sound being received by the AI because of the silence between the words. And that's where we see the difference between a synchronous and an asynchronous system. When no sound's coming to the AI is going to switch to a different task. And this task is going to be sending the audio to the speech-to-text software that we're using. It could be deepgram, it could be a lot of different software. But the point is, it's going to send that audio so that it gets transcribed into text. Now, of course, it's only going to be chunks of what the user is saying because the user is not done talking, right? We're talking about a pause between two words. And it's basically going to use that time to start transcribing what's happening. And so this way, the large language model that is under the hood is going to be able to directly access the text as soon as the user is done talking. And then we move on to step 3, which is the AI works exactly the same as the synchronous system because the sound is coming. So that's the real difference here. Now, it does seem like it's not a big deal, but the difference between a real-time and a non-real-time system is that for the non-real-time system, it's going to have to wait before the user is done talking before starting to transcribe the text. while the real-time system is going to do that while the user is talking. So this is not to be confused with multi-threading, which is a different thing. This is doing different tasks at the same time on a different threads of the CPU. This is just using the time that we have in a way that is efficient, optimized. And so the real-time framework that we can use is fastapi. Now, I want to be clear about this. Those two frameworks, they can both be used for real-time and non-real-time, for synchronous and asynchronous implementation. The real difference is that fastapi is async native and Flask isn't. That means that you're going to have to choose a specific concurrency model for Flask, and you're going to have to choose different types of libraries in order to implement those things. Now, I'm going to explain what I did and what I did wrong so that you can choose the right path, because there are 3 things that you can do if you started with Flask. So first, I created an app using Flask because it's the simplest way to go, right? So as I explained before, it's not directly asynchronous, so we cannot use it like that. So I had to install libraries. And then I need to use a concurrency model so that we can switch between tasks while nothing is happening. And then you see that there is an S at the end because I had to install multiple concurrency models because the speech-to-text software that I was using a different one. And then I needed to update the app starter because the way you run Flask using asynchronous kind of tools is not the same way as you do normally. And of course, there was compatibility issues with all of those things. And so that's the type of problems that you run into when you are just doing the worst thing possible. So just to be clear, those layers of complexity accumulated over the course of multiple days. And so that's why that became a problem, because you add a layer of complexity to solve what you think is the problem, but then it creates a different problem and a different problem. And then you keep adding layers and layers, and then the code becomes impossible to debug. So the point here is don't do that, and I'm going to tell you what to do instead. So before I get into the actual actionable advice, I know that it can be very tough to get started creating your own AI. And if you're watching this, that's probably one of the things that you want to do. And if you're a very beginner, I know that it can be tough to get started. So that's the reason why I created a free online course that you can access by just clicking on the link down below. So now let's get back to it. So if you have an already existing Flask application, what you could do is do not use multiple concurrency models if you are going to do that. Because here is the thing, you can still use Flask, but you really need to be careful about the layers of complexities that you're going to add to Flask. Otherwise, it's just going to make it impossible to debug and to move forward with it. So just make sure that you're not mixing multiple concurrency models and that you're implementing everything with a single library. So that's the most obvious path, and that's the one that you probably should do if you're really short on time, right? That's the fastest one. But down the line, that's not necessarily the best thing to do. Because the best thing to do is probably to migrate to fastapi or any type of asynchronous native framework. Now, depending on your app, that might not be the best thing to do because it might end up taking too long to do that, right? And so if that's the case, then you might want to think about creating a new server. So what do I mean by that? You create a server that is async native using an async native framework, and then you use that other server in your existing app. Now, there are trade-offs to this, but that might end up being the best solution for you depending on your situation. The good thing about it is if you install that new server on a different computer or a different server, like a different EC2 instance on an AWS kind of platform, this is something that could be very useful if you have high traffic, a lot of users that are going to use this specific thing. Then you can manage that traffic separately, right? You have a different computer, literally. Now, of course, the problem is you now have 2 servers, meaning you have probably like two GitHub repos and you're going to have two CI/CD pipeline. So it's more difficult to manage. But those are the three options that you have here if you want to do this properly. I hope this was helpful. See you in the next one.